Now we are discussing about algebraic structure and some more questions on algebraic structure. It is not the new things. Anyway, we have to define this algebraic structure. Algebraic structure and an algebraic structure is consisting of set G under an operation asterisk on a set G is denoted by G, asterisk will satisfy one or more of the following characteristics. Number one, that is closure property. We will repeat this in many times according to the condition. If a comma b belongs to G, then a asterisk b belongs to G, that is closure property. Number second is associative property. If a comma b comma c belongs to G, then a asterisk b asterisk c equal a asterisk b asterisk c. This is associative property. And number three, commutative property. It means if a comma b belongs to G, then a asterisk b equal b asterisk a belongs to G. And number four, existence of identity element. Existence of identity element. Existence of identity elements. If a belongs to G, then there exists an element, suppose E belongs to G, such that A asterisk E asterisk A is A, then E is an identity element of set G. A asterisk A is E asterisk A equal to A, then that is existence of identity element. Closure, associative, commutative, identity, and the final is maybe the fifth one is existence of inverse element. If A belongs to G, then there exists A dash belongs to G, such that A asterisk A dash equal A dash asterisk A equal E belongs to G. The inverse and the number product is E, or identity. Then if this satisfies, then A dash is the inverse element of A. So associate closure property is here, A asterisk B belongs to G. Associative property, if ABC belongs to the set G, then A asterisk B asterisk C within the bracket, and first operate A and B, then C asterisk is this. Commutative property, A asterisk B equal to B asterisk A, that both belongs to G. Their result is belongs to G. They are equal, but they should be on G. Existence of identity that A belongs to G, then E also belongs to G. But the product or the operation of A asterisk E is A, or E asterisk A is A. That should be fulfilled. And 5 number, existence of inverse. Inverse is A dash, we suppose A asterisk A dash equal A dash asterisk A equal to E belongs to G. The product is E or the product is A itself. So we have to suppose existence of identity, inverse, closure, associative, and commutative. This is the algebraic structure. Now we have to discuss a problem. Question number 1. Determine the identity element and inverse element of 3n minus 2 if an algebraic structure Z dot with binary operation dot defined by m dot n equal m plus n plus 1 for all m comma n belongs to Z. Now the solution of this. Here the given algebraic structure, that is Z dot, and for all m comma n belongs to Z, and m dot n equal m plus n plus 1. So what we should find, that we have to find the identity element and inverse element of 3 and minus 2. We have to find. Operation is this, binary structure is this, m dot n equal to m plus n plus 1. So let E be the, we have to suppose A symbolic identity element of 3. Then what to find? Identity of 3, inverse of 3, identity of minus 2, inverse of minus 2. So I have suppose E be the identity element of 3. First I deal 3. Then what is the property, or what is the structure shows us 3? Yes, 3 dot E should be 3 dot E, that is the operation. Then that is in the form m plus n plus 1, that is 3 plus E plus 1. E be the identity element. Yes, identity elements. Then in the structure m dot n equal to m plus n at 1, and we know 3 dot E is 3 itself. We know from the algebraic structure of existence of identity element, A asterisk E is E asterisk A is A. That's why 3 dot E here, instead of asterisk we use dot. That way 3 dot E is 3. Yeah, I have written the result is E plus 1. 3 gone, that's why E equal to minus 1. E equal to minus 1. Therefore the identity element, identity element of 3 is minus 1. First part is completed. Now again we have to deal about the inverse. Let A be the inverse element of 3. Then what we'll get? 3 dot A equal 3 plus A plus 1. The structure is m+n+1. And 3 dot A is what? E. It is E that we know. Inverse element is A asterisk A dash equal to E we have written. That's why here 3 dot A instead of asterisk we use dot here. 3 dot A is E. We put that. And here 3 plus A plus 1. What is the value of U we can take from here? That is -1. -1 equal 3 plus A plus 1. And 3 plus 4 is 5. 3 plus 1 is 4, shifting to the left, therefore A equal to -5. Hence, after getting A equal to -5, what we can write? Hence, the inverse element of 3 is -5. First part is completed. And again we have to move to the second part, that is of about -2. Yeah, so again we have to suppose let E1 be the identity element. E1 be the identity element of -2. Then -2 dot E1 equal -2 plus E1 plus 1. m+n+1 structure is that. And -2 dot E1 is -2 itself equal -2 plus E1 plus 1. -2 cancel, therefore E1 equal to -1. Hence, identity element of -2 is -1. We obtain the same result of 3n -2. Now we have to move to the next part. Also, let A1 be the inverse of -2. Then -2 dot A1 equal -2 plus A1 plus 1. Then -2 dot A1 is E1 because the inverse product of inverse is identity. And -2 plus A1 plus 1. What is the value of E1? That is -1. Or -1 equal -2 plus A1 plus 1. And then -1 shifting to the right, that is +1. 2 plus 2 0. Therefore A1 equal to 0 we get. From the simplification of that part we can get A1 is 0. And hence the inverse element